Hi, everybody. So, this is an overview of the first topic within our Unit 6. And our Unit 6 is working a bit differently because we are doing Unit 6 through a project with many of the other subjects. So, within this project, the math portion is you're going to be needing to look at data, analyze the data, and present the data. And so basically, here, this quote, the goal is to turn data into information and information into insight. And so in this project, you're going to have to be looking for some data and using that data to tell a story about the problems that you're seeing in the world and some of the solutions that you might have. So when we collect data, there's two different types of data we can look at. Primary data is when we collect from firsthand sources. So, for example, you go around the school and you ask a survey, you ask people some questions, you interview people, you do an experiment. That is primary data. Secondary data is when you are looking at data that someone else has collected through primary sources. This is what you're going to be using for this project. So you're going to be looking at different websites and looking at different pieces of data that other people have collected and made available for you. What's really important with secondary data is that you provide your sources. So within this PBL that you're going to be doing, and the bottom's cut off there, I think, I don't know. It is on my screen. I don't know if it will be in the video or not. You need to, number one, find reputable websites. You need to make sure that the data that you are finding is accurate. And your teachers will give you some resources and we will give you some support with that. You also want to make sure that the data that you're collecting supports your ideas and your solutions. So for example, if you are looking at different countries and the income, so the GDP of a country, and looking at access to clean drinking water and making conclusions like, man, these richer countries seem to have better access to drinking water and less people are dying, less people have health concerns. Perhaps a solution is to, help these poorer countries with getting access to clean water. If you found some data that said that, poor countries had excellent access to clean water, that doesn't support your idea and your solution. So you want to make sure that whatever you're saying, the data that you find supports those ideas and conclusions. And if consistently you're finding data that does not support it, then perhaps you need to look at your proposed solution or ideas. Again, your teachers can help you with that. For this project, you need to present your data in a table and in a graph. And in fact, we're going to be making a couple of different graphs. You also have to be prepared to explain the data and what it means and how it connects to your ideas and your solutions. So basically, this last point, which I don't know if you can see or not, it's what story is that data telling you? You're going to make a claim based on what you see. So you're going to say, hey, look, I see that there's a positive correlation here. And if I can improve this thing, then I think this other thing could also improve. So you're going to make some conclusions based on what you see. So, how do we present using a table? So, tables are going to look at numerical data in concise and accurate form. It's a really quick glance at just a whole bunch of numbers. The purpose of the table is to communicate information and allow you to make a comparison. Your table should have a brief title that is descriptive. Don't make a title that just says table, right? Or table of numbers. Like, make sure it has a descriptive title. You also want to have labels for your columns and your rows. And this last point, which again, I don't know if you can see or not, you want to make sure that you have sources. So making sure that you give some sources. So again, here is an example of a table. I have a title, a descriptive title. I'm comparing the sea ice extent, meaning the volume or the surface area of ice, to some global average surface temperatures over some of the past, 25 years, 30 years, 40 years. So I have everything labeled. I've got my data in a table and I have my sources listed. Now, obviously, a table is sometimes more difficult to interpret than a graph might be. I've got to actually look at the numbers, but I can see very quickly that in 1980, I had 7.54 million kilometers squared of ice. And in 2020, I only had 3.82. And look at the difference in temperature. And although it doesn't seem like a lot, a tiny, tiny change in temperature is huge for the environment. When we are presenting our data using a graph, again, we want to think about the purpose and what type of graph we want to use. We also want to decide if we want to graph by hand or technology. We're going to give you some resources to show you how you can use Google Sheets or Excel to make graphs. It's super easy and super fast. It would be my recommendation. But if you prefer to graph by hand, that is totally fine. Make sure when you make a graph, you have a title. If applicable, you have a vertical axis label and scale and a horizontal axis label and scale. What's also important with your axes is that the scale is consistent. So you can't have you can't go 1, 5, 17, 200, right? You want to go 5, 10, 15, 20, 25, 30. So your scale needs to be consistent. Your vertical scale and your horizontal scale do not need to be consistent with each other. They just have to be consistent on their own. And again, you also need to include a source. This is going to be extremely important because you're going to be taking data from other places, and we want to make sure that that data is accurate and that you're using reputable websites. So you need to list your sources. So what are some reasons why we graph? It helps us to make sense of the data, right? When I just have a whole bunch of data in front of me, sometimes I can't make conclusions. So the data is presented in a visual, easy to read way. It can help me to analyze and interpret and make conclusions. You will be asked if you would like, as an option, to watch this video here, which goes through the different types of graphs and when to use what type. Because you don't just use any graph you want. There's particular reasons why you might choose a bar graph over a line graph, over a circle graph, etc. So here's a couple of examples of bar graphs. These are on the left, a single bar graph, and on the right, a double bar graph. We use bar graphs when we want to depict categorical information. So we're looking at things that would be in categories. How do you get to school? Do you get to school using a bus, using your parents dropping you off, walking, biking, etc.? Those are categories. A double bar graph might be used if we're separating, say, by gender or by age or things like that. So where we want to make a comparison between a group and then looking at how that group answered in terms of categorical data. Again, you'll notice titles, labels, all of those things are there. This is a circle graph. So a circle graph is used when you want to compare parts to a whole. So if I was looking at, a country's money, so Canada, the country of Canada, and their budget, and I want to look at how they spend their budget, I might use a circle graph because I'm looking at how each piece relates to the whole. I have all my money. Where does the money go? In a circle graph, you're going to be using percentages because it's a way to consistently show the part to a whole. And if you are making a circle graph by hand, you're going to want some support from your teacher because it's a little bit tricky. If you're using something like Excel or Google Sheets, it's pretty easy to make your circle graph. You will also see circle graphs referred to as pie charts in some places. Again, you'll notice a table, you'll notice labels. So those things are really important. A line graph is for things that show change over time. So this is looking at sea level and how sea level is rising over time. I would say that this title is not a particularly great title. It's sort of a leading title. It leads you to make a conclusion. You want to try to avoid that. So a better title might simply be sea levels over the years, something like that. Notice that in the line graph, you're going to plot your points and then the dots are going to be connected to show change over time. So we use line graphs for things like temperature, something like the stock market, for example. Money's, you're gaining money, you're losing money. You might show a line graph for that, or looking at, the value of the Canadian dollar compared to the US dollar over time. So things that are showing change over time is a line graph. A histogram's a little bit of a trickier one because it looks like a bar graph. It's very similar to a bar graph, except notice there's no spaces between the bars. And notice that you have intervals. So instead of saying, this is a bar for the people that like pizza, and this is a bar for the people that like ice cream, and this is a bar for the people that, don't like junk food, you have bars showing your interval of data. So it's often used, like this example here is like to look at marks, how many people fall in each of the ranges of marks. it's looking at anything that would be numerical that you could divide into intervals where the individual pieces don't matter. It's really looking at the intervals that make a difference. So it's really looking at frequency within the intervals. I'm not sure for this project how common a histogram will be, but it's still a useful thing to know how to do. So, for example, if I measured everybody's heights and I wanted to show that, I don't want to show a bar graph with like 100 different people's heights. I might show a graph, a histogram, that's how many people are, between 1.4 and 1.5 meters. How many people are between 1.51 meters and 1.6 meters, etc. Finally, a scatter plot, and we're going to go into more detail about scatter plots, but basically you're looking at a relationship between two variables. You might have looked at this in science class. So we are plotting points here, kind of like a line graph, except notice we're not connecting the dots and showing change over time. We just have a bunch of dots, and those dots will represent a trend. In this case, it's showing a negative correlation, and you'll learn more about that later, but it can show all kinds of things. It might even not show a trend at all. And usually with a scattered plot, once you plot your points, you're going to do a line of best fit to represent the trend that you're seeing. Again, the weakness of the graph example here is there's no title, right? You want to make sure you always have a title. So you are going to need to show us sort of that you can graph, that you understand how to graph, so that we can give you support if you need it for your project. So there's 2 slides that you're going to have to be completing. So these are your tasks. There's some data that we've collected in the past from grade 8 students. That data you will find in your drive. And you'll have an editable copy that you can actually make your graphs directly in that Google Sheet. And then this is just a place where you're going to be copying and pasting the graphs. So you have to do 2 graphs. There is a link down here, graph choices. If you click that link, it tells you specifically, so I'll show you that. So for graph number 1, you can choose to graph birth month, favorite sport, or favorite kind of ice cream. And you're going to choose what type of graph you think would be best to represent that. Graph 2 must be a histogram, and you're going to choose to graph either minutes active, minutes playing video games, internet, etc., or minutes doing homework. And there are some resources within this to help you, to show you how to use Google Sheets to make graphs, how to make a histogram, etc. Later on, you're going to need to do a scatter plot as well. And again, your teachers are there to support you and help you, but that just gives you an idea of what you're going to be needing to do. And that is it for part 1.